In conductors, it is not possible that you direct the energy at your own will, as it happens in mobile. You only operate that app which you want to operate. Hello everyone, a very good afternoon. Guys, today we are going to discuss a very important and interesting concept of semiconductors. Okay, Prateek, I am going to take care of your physics optional. So guys, today we are going to talk about intrinsic and extrinsic semiconductors. Now, before moving on to intrinsic and extrinsic, I just want to give you a brief introduction of semiconductor. We have discussed semiconductor in length in another video. Okay, here we have to focus on intrinsic and extrinsic semiconductor and also on p-n junction diode, okay, if time permits, but mainly on intrinsic and extrinsic semiconductor. So, but in order to proceed with it, we should have an idea that what actually semiconductor is. So I'm going to brief you out. Guys, we know that we have got conductors and conductors have got free electrons, right? Conductors have free electrons and these free electrons are present on the surface of the conductor. Since due to these free electrons, electricity, heat, all these things are conducted or transferred from one end to another end in conductors. Okay, and why these free electrons are formed, we have already discussed it, but I'll tell you again. Because mostly the conductors have got large size, so electron present in the valence shell, in the outermost shell, they are not under that much influence of the nucleus. The electrostatic force acting on them is smaller, right? Or you can say is negligible. So these electrons, they move out of their respective atoms and they migrate or roam freely. They roam freely on the surface. Okay, so that's why conductors conduct. Then we have insulators. Here no free electrons are present, and no free electron means no conduction. They are not going to transfer electricity or heat from one end to another. So guys, if we want to make devices, now your mobile is a semiconductor device. Just imagine, it's not possible, it's a hypothetical situation. I am just asking you to imagine so that you can have a clear concept. Just imagine your mobile is made up of conductor, any conductor, let's say copper. So guys, you have got so many apps in your mobile. What will happen if your mobile is made up of copper? As soon as you switch on your mobile, all the apps will start operating simultaneously. Yeah, because in conductor, if you are transferring the energy, energy will get transferred. You cannot stop the energy depending on your will. The only way to stop the energy is plug out. Yeah, turn the switch off. And if you turn the switch off, then no flow of energy will be there, right? In conductors, it is not possible that you direct the energy at your own will, as it happens in mobile. You only operate that app which you want to operate. Other apps are closed. But if you use conductor to make a mobile, all the apps will operate simultaneously. My God, that's the thing to worry about. So conductors cannot be used to make electronic devices. Insulators, no transfer of energy. So it's a waste, no use for it. Then what to do? So guys, this problem is resolved by semiconductors. They conduct when we want them to conduct. How? So I'm just going to brief it out again because I've done energy band diagram in another video. But see guys, if we draw the energy band diagram of the conductor, insulator and semiconductor, So please see, there are two bands. One band is known as valence band, another band is known as conduction band. Okay. In case of conductor, these bands overlap. Okay. Electrons are present in valence band when you are not providing, or when we can say in simple words, in their relaxed state, electrons are present in valence band. Okay, but since valence band and conduction band are overlapping in case of semiconductor, so these electrons, they can easily move on to conduction band and they can start conducting, right? That's the case with the conductors. Okay. If you talk about insulator, so guys, in case of insulator, I'm going to erase it. Yeah. In case of insulator, the gap between valence band and conduction band is huge. Okay, and this is known as energy gap. The gap between valence band and conduction band is huge. So electrons cannot jump from or move from valence band to conduction band or conduction because the gap is huge. Transition cannot occur, right? There cannot be transition. No, that is why no conduction takes place in insulators. What happens in the case of semiconductor? That yes, there is a gap between valence band and conduction band, but the gap is not too large. Gap is not too large, and electrons are present in valence band. So, if you provide this valence band or this semiconductor with some energy, let's say heat energy, you are providing the electrons present in the valence band with the heat energy, then under the influence of this energy, these electrons can easily move to conduction band and they can start conducting. The name itself is suggestive. Conduction band means the band where electrons will move and conduction will take place, right? So now see, if you want semiconductor to conduct, you provide the required energy. So electrons from valence band will move to conduction band and they will start conducting, right? So it is at your dispose, at your choice, that when you want semiconductor to conduct. This was not the case with conductors. Valence band and conduction band were overlapping. So electrons could easily migrate on their own and they could start conducting. Whereas in case of insulator, you keep on providing energy, but the gap is so wide that the jump or the transition of electron from valence band to conduction band will not take place. Fine. So that's the basics of it. Okay. I have already discussed in detail the energy band thing in another video, but here I wanted to brief you out so that we can start with our topic at hand. Now let's talk about intrinsic semiconductor. So guys, tell me, what is the meaning of intrinsic? If you talk about intrinsic, what is intrinsic? What is the meaning of this? Okay, let me give you an example. If you take the example of magnet, suppose there is a magnet. So magnet has got intrinsic property of getting attracted to iron and its alloy. Magnet gets attracted to it. It's the intrinsic property. This property was not acquired by magnet, but wherever magnet is present, it will have this quality. Intrinsic means your pure quality, your quality. Intrinsic means something with which you are born, right? So intrinsic semiconductor means pure semiconductor. And guys, when I am saying pure, in case of semiconductor, in case of electronics, I do not mean pure and impure doesn't mean that some impurity or dust particles are present. No, no. Pure means that semiconductor is not inhabited, or there is no other, in simple words, no other particle present inside the semiconductor. Sir, can another particle be present inside semiconductor? Yeah, that's the process. We'll talk about it. Now, we all know about carbon in chemistry. We know about the group called as carbon family. Carbon, silicon, germanium. So out of this group, silicon and germanium are used as semiconductors. In carbon family, all these carbon family members, they have got 4 electrons in their valence shell, right? Including carbon. So sir, why only silicon? A question that you can ask is that why only silicon and germanium are used to make semiconductor? They belong to the same group, and in group, the thing is that all the elements possess nearly same property. Then why only silicon and germanium? So see guys, if you talk about carbon, the first member of this group, then the energy gap that I just talked about, Eg, is too large between valence band, and energy gap is between valence band and conduction band. So since energy gap is too large in case of carbon, carbon cannot be used as a semiconductor. Rather, carbon is used as a insulator. It is an insulator. Silicon and germanium. Silicon and germanium, they have adjustable, or you can say moderate amount of energy gap. Not too high, not too low. And out of these two, silicon has 0.7, germanium has 0.23. So out of these two, germanium has lower amount of energy. Fine. So these two are used as semiconductor. So intrinsic semiconductor means either silicon or germanium. Okay. Pure silicon, pure germanium. No other element should be present. Only pure silicon or pure germanium. Fine. That's what intrinsic semiconductor means. Now the thing is, what we observed was that at room temperature, pay attention guys, this is important. At room temperature, that means 30 to 35 degrees centigrade, some say 32 to 37, whatever. So I'm just taking an average 30 to 35 degrees centigrade. At room temperature, what was observed that out of 5,000 electrons present in the valence band, only 2 electrons got transferred to the conduction band. That means when you are providing your semiconductor with the temperature of 30 to 35 degrees centigrade, only 2 electrons are moving. And guys, this is just a figure, okay? And figures can vary. Different books illustrate different figures. But to give you an idea, so out of 5,000 electrons present in valence band, only 2 electrons traveled from valence band to conduction band. And conduction takes place in conduction band only, remember? So when only 2 electrons are moving from or transitioning from valence band to conduction band, then how can conduction occur? 2 electron is very small amount. Current that will flow due to movement of 2 electrons, that will be negligible. So what to do now? If no problem, increase the temperature. Yeah, that's an option. Okay, how much will you increase? will you increase it to 100 degrees centigrade? That's the boiling point of water. And guys, can you put your hand inside boiling water? So how can you hold that device at 100 degrees centigrade or even more? So that was not feasible. That was not possible. So in case of intrinsic semiconductor, despite of being a semiconductor at room temperature, it did not conduct. Why? Because electrons did not migrate from valence band to conduction band. So this became useless for us. Right or wrong? I'll write it. At room temperature, I've written temperature in short. Conduction of electrons from valence band to conduction band was negligible. So guys, this made intrinsic semiconductor useless for us. The purpose, we wanted to develop electronic devices. The purpose for which we were doing all these things. Else what was the need? We were already having conductors and insulators. Why the need of semiconductor? The purpose of conduction at our own will, which we desired, was not fulfilled by intrinsic semiconductor. So we designed, or we converted intrinsic semiconductor to extrinsic semiconductor. Okay, so guys, I hope you understood what intrinsic semiconductors are and what was the problem with the intrinsic semiconductor that led to the discovery or manufacturing of extrinsic semiconductor. Okay, so now we are going to talk about extrinsic semiconductor in some other video. Okay, thank you. I hope you all enjoyed and understand. Bye.